Welcome back to Year 13 Maths. This is exercise 22b when we're looking at moments. And you should remember that moments has a formula, which is that if you got the force and you times it by the perpendicular distance, this is how do you find the moment. So it's force times perpendicular distance. And if you can't remember what a moment is, I would describe it as a turning force. It's probably the best way to think about it. What effect on something that might rotate. So here we've got a bar going across from the crane, and interestingly it doesn't mention any mass for this, so I'm going to assume that this bar, I'm going to call it a light bar, i.e. it has no mass. Now of course it has got a mass, but we're going to assume it hasn't. It's pivoting around this point here, so it could topple if you're not careful. And that's the idea of the counterweight, to stop it toppling, to force it back round. So we've got a W force coming down, and what's that? That's 3 meters. And we've got a 500 Newton force, and that's 15 meters away. So the trick is to realize that the anti-clockwise force here, this force would make it spin round this way, whereas this force makes it spin this way. This is a clockwise force. And we always basically, if it is in equilibrium, the clockwise forces must equal the anti-clockwise forces. So it just doesn't matter which way around you do this. I've written clockwise, so I'm going to write 3 times W must equal the 500 times the 15. 3W equals 7,500. So W must be 2,500, and W is a weight, so it must be in newtons. There you go. Second example. It's basically the same question. I had a look at this before. We've got a little boy here, and we've got a bigger boy here, and we want them to be able to sit on this plank of wood without it moving. We want it to be resting in equilibrium, and the way we can adjust it is we can move the pivot left and right. Now we don't know where it is that will be in equilibrium, and to find it, you pick a side. I'm going to say this side is X. And by definition, this little bit over here must be 5 minus X, because the whole thing is 5. Now notice again, we're doing this with the assumption in part A that the wood is light, so I can ignore the mass of this beam. In a bit I won't be able to. A plank of wood then is 5. Alright, so let's have a look at our picture. This is, again, because the pivot is here, I reckon this is a anti-clockwise force, and this is a clockwise force. So if I do anti-clockwise equals clockwise for part A, I will get the force times the distance. Well, that's 40x, and that is equal to the force in times the distance in the other direction. That's 60 times by 5 minus x. So quite straightforward to do that. 40x equals 300. Minus 60x, what's that, 100x equals 300, or x equals 3 meters. This is a distance this time, and I suppose I should say from the left hand side, because you've got to clarify what your x is. Don't just assume they've looked at your picture. Part B though has a weight to it, and that basically means this bar now is a solid bar. And one thing you should know is that weight always acts at the center, and that basically means it's 2.5 meters, because it's either side is 2.5. We've still got the 14 Newton buoy. The weight of the bar, what's it say it is? It says 20 newtons, and we've still got the 60 Newton buoy. And what it wants us to do is to work out the position of that pivot. And one thing I can say is you're not really sure which side it's on, I suppose. You don't really know if the pivot is on this side, and it could be on this side theoretically, or is it on this side? That, when I say is the pivot on that side, this side, what I mean is, in order to let these two boys still play on this piece of wood and sit there, where would the pivot be? Would it be on this end, or would it be on this end? And I suppose what I'm after is to be able to then, once I've sussed which end it's going to be, then I can do the sums. Well, the good news is, when I did some sums, I actually found it didn't really matter quite as much as I thought. So I'm going to put the pivot on this side. And I think actually, as long as you do the sums correctly, it turns out that it will work it out for you and put it in the right place. But anyway, let's do this sum. I need to call this something. What did I call it last time? I called this distance last time x up to there. And so again, this is 5 minus x to here. Chung, 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 chung. And I suppose I will need this distance. And the good thing is it's the 2.5 minus whatever this was. So, oh, hang on a bit. It's, well, I suppose this is an easier way to think of it. That is x all the way to there, and I take off that. That's the easier distance to use. It's x minus 2.5. So anyway, now I clarify. This is a anti-clockwise force. This is also an anti-clockwise force, but this one is a clockwise force. So I've already said that anti-clockwise equals clockwise. So I'm going to do 40 newtons times by what distance that away? That is x. Plus the 20 newtons times by this little distance, which is x minus 2.5. And that must be equal to 60 lots of, how far away is that? It's up to the 2 point there, so it's the 5 minus x. So anyway, so I end up here getting 40x plus another 20x minus 50. And that equals 300 minus 60x. Whack that over there, 40, 20, and this 60 is 120x equals 350. And if you do that, x is 350 divided by 120. 2.92. Now again, that's 2.92 from the left-hand side. Answers here. Good, got the right answers. So whenever an object is resting on a support, we must think about the normal reaction. So I've got here I'll draw a new picture. So we've got a bar. I think it says it's got a mass. Yes, it does. It says it's 100 kilograms. Be careful of that. So straight away at the middle, 5 distance away, we've got 100. Now I've got to write 100 G. This is 100 times by 9.8. That doesn't mean grams. It means 100 times 9.8. Now I've got a box here, and that's 2 meters away. That says a box of 40 kilograms. So it's 40 times 9.8. And this is 90. Is it man 90? No, it's 60 G. But one thing you need to remember is it's being supported here and it's being supported here. And what that does is it produces normal reaction forces. There's an X and there's a Y. The other thing we've got to do is we've got to decide where to take our moments from. Now, last question we had an obvious pivot. There was a pivot underneath about which it rocked, and then, it was obvious to put it there. Now, it doesn't have to be there, and in this case, I'm going to take moments from this end, at least initially. And the reason I'm doing that is because I need a point which is no distance from one of the forces I'm trying to find. Because there are 2 forces, you see. If I'm not careful, I'll end up with a formula which says x and y in the same formula, and I've got to get rid of one. If I take the moment at the end, then from this end, for instance, it's no distance from x, and therefore its moment is 0 times x. It will disappear, and that's what I'm after. So I'm going to take moments from x, and that's one way of doing it, showing it with an x with a little circle around it. So anyway, decide which is clockwise and anti-clockwise forces. This one I reckon is a clockwise force, a clockwise force, a clockwise force. Oh, and the only anti-clockwise force is that one. So I reckon, what are the distances? So from this one, it's 40 times by 9.8, distance of 2 away, plus 100 times by 9.8 times by, now that was at the center, so that's 5 away, plus, what was that? It was 60 times 9.8 times 9 away, and that is equal to, well, 10 away, 10 times by y, that's a 10. So if I work out that left-hand side, it'll take me forever to do that. 40 times 9.8 times 2 plus 100 times 9.8 times 5 plus 60 times 9.8 times 9. I get a whopping 10976 equals 10y. So obviously, according to me, when I divide that, I get 1097.6. What is this? This is newtons. Now, I could do the same thing to get the x at the other end as well. I could take moments from this end and I could do exactly the same. Or I could just use a basic idea that forces up must equal forces down. So what forces have I got? I've got forces up, I've got x plus y. And forces down, I've got 3 forces going down, so that's between them they have a mass of 200. So that's 200 times by 9.8, and I can just say those forces up must equal those forces down. 200 times the 9.8, I get 1960. And I already have said that y equals this, so I reckon x must be that, minus the 1097. So I'm going to do minus 1097.6, and I get 862.4. I've not looked, so let's see what 8. Oh, good, it even worked. Last example, I've got a uniform rectangular laminar. This will be harder because it's in 2 directions now. So it's got a width 30, height 20, a weight of 80, and it's a fixed bolt point D which can rotate. So okay then. So what I need to do is to think over here. So if I look at this bit over here, you can see it is effectively acting 15 away. So I've got that there, that 20 Newton force. There's a weight 80 and is attached to a point. I'm going to have to just pause and get my head around this. All right, I've got my head around the picture now. So basically we've got this force here of 20, but actually I'm going to say this is the 80. This is the 80 Newton force. I've shown you the answer, by the way. But the 80 Newton force is the weight. And obviously the weight acts at the center, but it's obviously going to act downwards from the middle. So the picture is, I think it's important that we have that at the middle because it's obviously acting at the middle. And notice the way I've gone upwards, I've kind of said to myself, well, the rule for moments is force times perpendicular distance. So I've taken that 80 newtons and I've gone upwards. Where it hits this straight across force, that's the distance I can find as a perpendicular force. It's got this 130 Newton tension, which it says it's pulling it this way. So again, I'm going to take this until it hits the side of this, and you can see that distance would be 10. Because it seems to be hitting it right in the middle. Yeah, it says midway. And the last thing, it doesn't really tell me where it's acting. I'm going to show this P to be there. And the reason I'm doing that is because this distance, we're not sure what that is, and I'm going to mark that as X. And P, it says, is basically a downward force of 20. And so I'm just going to draw upwards from there. And again, that X is like a horizontal force, horizontal distance. What I do for each force is I say, what does it affect? So this force which is pulling this way, I think would effectively pull it round. So I think that's an anti-clockwise force. Whereas these two, I think they would have the effect of pulling it down and this way around this pivot. So I think both of these are clockwise forces. So if I just do this quickly, I reckon 20 times that X plus 15 times by the 80 is equal to the 130 times by the 10. So this is 20x plus 1200 equals 1300. 20x is 100, and that is why x is 5. That's not easy, the last bit. So if you get these laminars, these solid objects, they're a bit harder. So there's some questions for you anyway. I want you to have a look at exercise 22b, and best of luck with that.